Okay, let's go on to section 1.2. So here they divide the study of statistics into two separate parts. So they have what they call descriptive statistics, which is kind of the simpler part of statistics, and then they also talk about inferential statistics. So let's see what's the difference between these two. So in so they say, okay, suppose we have information on test scores of students enrolled in our class. So I have my students and I have their scores. In statistical terminology, the whole set of numbers that represents the scores of the students is called the data set, or a data set. Okay? The name of each student is called an element. Now, I haven't really heard that terminology before, but okay, let's accept it. The name of each student is called an element. So we have Tomoko, that's an element, and Daisuke, that's another element, and William is another element, and so on. So those are the elements. And the score of each student, what they got, is called an observation. That's standard terminology as far as I know. Okay, so we have data set is all of the everything, and then the names are called elements, and the scores are called observations. A data set in its original form is usually very large. So, I might have a different data set like 100,000 people, information about 100,000 people. So if I have that huge data set, that's kind of very hard to work with, right? I mean, can't look at 100,000 names and numbers and so on and make any sense out of it just looking at it. Such data is not very helpful in drawing conclusions or making decisions. It's easier to draw conclusions from summary tables and diagrams than from the original version of a data set. So we reduce the data to a manageable size by constructing tables, drawing graphs, or calculating summary measures such as averages. So instead of looking at, suppose I had 100,000 people's incomes, yearly income, that's too much data to look at. But if I calculate the average of those 100,000 numbers, that's very simple and very easy to look at. So that's called a summary measure. It summarizes the data. Of course, when you summarize data, you make it simpler, but you also lose something by summarizing it, but you gain something in terms of being able to use it more easily. The portion or the part of statistics that helps us do this type of statistical analysis, that is drawing the graphs, constructing tables, calculating averages, or what they call summary measures. This part of statistics, this type of statistical analysis, is called descriptive statistics. So that's what we mean by descriptive. And then we're going to talk about what we mean by inferential statistics. But let's just see, here's an example of descriptive statistics, because this is a graph or a kind of picture of the data, right? We're not looking at the individual pieces. We've somehow summarized it here. What is this? 5 companies in the United States with the most patents. So we're not looking at all the details of all the patents. We've just summarized it into this pretty simple picture. Okay, so this would be part of what we would talk about. This would be part of descriptive statistics. Okay? Descriptive statistics consists of methods for organizing, displaying, and describing data by using tables, graphs, and summary measures like averages. Okay, so that's what we mean by descriptive statistics. Now, inferential statistics is another thing that statisticians will do and that you have to learn about, that's different than just descriptive statistics. So let's say, let me look at my terrible picture here. So this is supposed to be the United States. And suppose I have a new app. Okay, suppose I have a new app, and I want to sell it in the United States. Of course, I can sell it in the whole world, but I'm just focusing on the United States right now. So suppose I want to sell this app, and I want to see, you know, whether people are going to like it or not. And so I'm going to give it to a bunch of people. So I'm not going to give it to everybody in the United States. I'm just going to give it to a sample of a few people. Here's a person, here's another person, another person, another person, another person, and so on. So maybe I'll give it to 100 people or 1,000 people. Okay? And then I'll ask them, you know, please rate my app from 1 to 5. 5 means you really love it, and 1 means you don't like it, and so on. Okay? So we say that I want to know what everybody in the USA thinks about it, but I can't give it to everybody. So I just give it to a sample of the entire country. Okay? So we call the entire country, in this case, we call it the population. The population means the whole set of data, the whole set of people or individuals. It doesn't have to be people, actually, because we could be talking about something where suppose we're trying to understand, like I produce light bulbs, and I want to know something about all the light bulbs that I produce, but I can't look at all of them. I can't test all of them, but I can test a sample of them, and I test the sample to know about all of them. Okay, so the sample gives me an idea about the whole set of them. So then we call all of them the population of all the light bulbs. So, sorry about that. So then what that means is that the population doesn't have to refer to people, actually. Can be light bulbs in that case. Okay, but anyway, so here all the people in the United States would be called the population, and then the ones that we choose to maybe observe, particular ones, are called the sample. So we distinguish between population and sample. We use those two words. So they say, in statistics, the collection of all the elements of interest is called the population. The selection of a few elements from this population is called a sample. Okay? A major portion of statistics deals with making decisions, inferences, predictions, and forecasts about populations based on results obtained from the sample. So, in other words, going back to this example with the app, so I can't ask everybody in the whole population whether they like the app or not. Actually, these days you might be able to, but usually you can't. But you can ask a sample, and then based on what you find out from the sample, you're going to make a guess about what the whole population thinks. Like if 80% of the people in the sample like my app, then I'm going to say maybe I could say that 80% of the whole population likes my app. So we go from the sample to the population, right? Oh, by the way, the word inference just means guess. Basically it means guess. It means scientific guess. Okay, a little bit better than guess, but more or less guess. Guess based on some data, maybe we can say. A major portion, let's read this again. A major portion of statistics deals with making decisions, inferences, predictions, and forecasts about populations based on results obtained from samples. Okay, so this part of statistics, so this is different than what we call descriptive statistics, which was just looking at a few numbers or making some tables or things like that, where we're just kind of describing the data. Okay? Here we're doing something different. We're making guesses or inferences about a population based on a sample. So that's a kind of different process, different study than what we were talking about above. So we called one of them descriptive statistics and we called the other one inferential statistics. Okay, so they say, for example, we may make some decisions about the political views of all college and university students. So I want to know what everybody at APU thinks about some political issue. But I don't want to ask everybody. So based on the political views of 1,000 students selected from a few colleges and universities, or based on maybe just 100 students selected from APU, I'm going to guess about everybody at APU. Or, as another example, we may want to find the starting salary of a typical college graduate. But we're not going to ask every college graduate. So we may select instead 2,000 recent college graduates, find their starting salaries, and then make a decision based on this information, or make a guess about what the starting salary is for all college students. So in that case, all college students would be the population, and 2,000 in this case would be the sample. Okay, population and sample. The area of statistics that deals with such decision-making procedures is referred to as this one. Inferential statistics. So descriptive statistics and inferential statistics. We can divide our class, our study of statistics in this class, into, first we're going to study descriptive statistics, and then we're going to study inferential statistics. He says this branch of statistics is also called inductive reasoning or inductive statistics. Inductive means, I think it means reasoning from a specific example to a general example. So from a sample to the whole population. Okay? Inferential statistics. Inferential statistics consists of methods that use sample results to help make decisions or predictions about a population. Okay, and here's some example. You can look at it in the book. I won't go through it right now.